structures we have discussed, and I told you it is basically a user defined data type. So here we
Yes,
combine
sir.
the multiple entities to one unit called a structure, and by using this we can use for one particular entity we can use multiple data types, maybe an integer or a float, anything else can be used. Okay, I have another example here that shows that how the structure is going to be used. So here you have a classroom, and related to the classroom, we have few details: room number, total number of students, pass percentage, and subject. Room number, total number of students, pass percentage, and subject. So now we will have a program that is related to the structures for this program. So you can see that here, and fine. So okay. Now tell me in which line you have the definition for structure, in which line you have the structures, the definition for structure.
Says 7, 8, 9.
It starts from
7.
no, the entire structure detail starts from where?
Sir, entire structure starts from 6. No, 4.
5.
5.
5, sir.
Oh, sorry.
Line number
Structure
5.
classroom.
Line number 5 you see
Sir,
the structure classroom.
Yes, sir.
Okay. Then
okay, sir.
as we seen in the example, so what is there in the example? You can see that you have a room number. Room number generally we will be having in integer, right? Room number
Yes, sir.
are declared it is in integer. Then total number of students also now we will be having in integer. Number of
Integers.
students. Then what you have? You have a subject. Got it? Subject we are going to use it by we are going to take it by using character. Then also we
Character.
the pass percentage may be in
Float.
hmm, so it may be in floating value. So what we have done now, a classroom is a structure which consists of integer data type, character data type, float data type,
460.
and also a float. Okay.
Okay.
Now,
Now,
okay. Now, structure, and also I told you, in order to make use of the structure, what do we have to do? We have to define a variable for the structure. Okay. So, what are the variables we have here? Classroom and lecture hall. Classroom and lecture hall. This classroom is the name of the structure. This classroom is the name of the structure. Then you have two names for a classroom, or two variables for a classroom, that is classroom and lecture hall. Okay. Then, and now you see that for a room number of class RM, for room number of class RM. Okay, got it. So now when you say a class RM is also a structure now. Got it? Like a classroom, this also will have integer, character, and float. Okay. Similarly, lecture hall also will be there. Now, in classroom room number, the what we can value is given here, that is 203. Then similarly, total number of students 54. Then classroom that percentage is 75.6. Got it? Then we have written some cout statement. You can see the cout statement, how it is written here. It is generally to enter the name of the subject is going to be displayed. And now when you take the value, okay, into the system, then we need to specify to which variable we are going to take the value. Okay, so the subject of classroom will be assigned with the value whatever that we are going to give. Okay, then room number is going to be displayed, but what room number? The room number of class RM will be displayed here. Then total number of students also will be displayed from the class RM. Similarly, you can see that the same thing is done here for the lecture hall room number with the value 205. With the value 205. Then total number of students 95, pass percentage 100. Okay, like this. And here also you can see that when I use the statement to, yes, when I use a statement to display the value on the screen, you can see that a corresponding structure will be used and corresponding member of a structure also going to be specified here. Got it? Okay. Any idea what will be the output of this program? Any idea what will be the output of this program?
Sir, it will give us the classroom number, number of student, percentage, and all those details.
Okay. In somebody's mic is on and the TV is also on here. Just mute it. Okay then. So now I'm just going to run this program. So if I run the program, so it will show enter the name of the subject. So I'm going to enter the name of the subject for classroom first. It's going to be in sequence, right? Then it will show, now you can see that room number 203, total number of students 54, pass percentage and the subject. Got it? Then again it's asking us to enter the name. Got it? So we are going to enter the name machines, and already that now I hard coded the room number and the total number of students, so that also will be displayed there. Understand? So by using different structures, we can specify different values for the members of a structure. So now if we look into it, the structure accepts integer, floating and character. Similarly, this structure also accepts the integer, floating value and character value. Tell me, any doubt with this program? You can ask me now. Union is another user-defined data type, and union is basically it's very similar to structures. Structures, just now we have discussed that. So it is a module or a block in the program statement, and what we can do is we can collect different data types into one particular unit. That's called a structure. So it is similar to the union is also similar to structure. So what it does, it groups dissimilar data types, dissimilar types of elements into a single unit. Like a structure, union also does the same thing. And where is the difference actually? The difference lies in implementation. The difference lies in implementation. So what is the implementation different here? We look into it. The size of the structure is equal to sum of the sizes of individual member types. The size of a structure is equal to sum of the sizes of individual member types. Okay. Whereas the size of the union will be the size of the largest member element. Size of the largest member element. That's a basic difference. Otherwise, both structure and union are same in every way. Only except this in terms of implementation. So in implementation, the structure it is the size of the structure is equal to the sum of the sizes of individual member types. Then in union, the size is equal to the size of the largest member element. Largest member element. Okay. Then let us understand the difference between structures and union. The difference between structures and union. Okay. So I given here structure of the classroom what we have discussed just now, and also I have discussed here the union. As I told you, there is no big difference except the implementation part. So here we have struct and here we have a union. That's the only difference. Otherwise, you can see that in every way, all the details are remain same. Okay. Now the structure, when it's getting implemented, it occupies 8 bytes of a memory. Occupy 8 bytes of a memory. And also I told you how it is basically different. Some of the sizes of individual member types. Some of the sizes of individual member types. Got it? So if you look into it, it occupies 8 bytes of memory. How it occupies 8 bytes of memory? Because to store an integer variable, you need 2 bytes of memory. And to store another integer, you have another 2 bytes of memory, totally 4. Then to store a floating variable, you need 4 bytes of memory. So 4 plus 4, 8 bytes of memory is required. Got it? Whereas when the same thing is implemented in union, it occupies only 4 bytes of memory because the size of the union is equal to the size of the largest member in the union. So what is the largest member? This is also 2 bytes. Integer is also 2 byte. Whereas floating is a
4 bytes.
floating is a how many bytes?
4.
Floating is
4
4
bytes,
bytes. So this is the largest size. So for this only the memory area will be allotted. So it occupies 4 bytes of memory area. Understand? That's the difference between structure and union. So once again, now we can have theoretical differences between structure and union. The structure is defined with the struct keyword, whereas union is defined with union keyword. And all members of a structure can be manipulated simultaneously. Okay, whereas the members of union can be manipulated only one at a time. Only one at a time. Then size of a structured object is equal to the sum of the individual sizes of the member objects, whereas the size of a union object is equal to the size of largest member object. Then structure members are allocated distinct memory locations. That means we have 3 variables, right? In a classroom structure, we had 3 variables. So for each one, the memory will be allocated in different areas, in different places. Whereas for a union, a common memory area will be used, and it is used for exclusively for storing the union data members. Then structures are not considered as memory efficient in comparison to unions, whereas unions are considered to be memory efficient. Okay, and when the members are not required to be accessed simultaneously. Structures in C++ behave like a class. Okay, whereas union, it retain the core functionality in C++ with slight add-ons like a declaration of anonymous unions also possible. Okay, so these are the basic differences between the structure and union. So in user-defined data type, we have discussed the 2 data types now. One is a structure and other one is a data type. So with the structure and the union, what we can do, we can group dissimilar data type together, which is logically related for a particular application. Understand? Any doubt with this?
Sir, point number 4, structures are not considered as memory efficient. I mean, what do they mean by memory efficient in this, sir?
Structures are not considered as memory efficient means?
Yeah, in this comparison, I want.
Yeah. Here, what is that means? See, if you look at the previous one, no, that some structure members are allocated distinct memory locations, and also here what you have to do, we can access the element of or members of the structure simultaneously. Understand? So that means
Yes, sir.
whenever you access a data member of a structure, a memory area need to be allocated. Understand? Whereas in
Ah,
union,
yes, sir.
what will happen now? You will whenever you are going to use only one data member at a time, only one data member at a time. So whenever the members are not required, that you need not to give or given memory area. You need not to allocate a memory area. Understand? Because
Yes, sir.
structure, you know that size of the structure is equal to the sum of the individual sizes of the member objects. So for integer, you require two bytes. So that is need dedicatedly it should be there. Then similarly, what will happen? Another integer, you have another 2 bytes. Okay. Then one more float you had. For float, you need a four bytes of memory. You must allocate. Understand? So totally, how much you have to allocate?
8, sir.
8 bytes of data allocate. But whereas here you see that in union, got it? So you are going to allocate
Yes,
only
sir.
4 bytes of memory area. Got it? So in this 4 bytes of memory
Yes, sir.
area only, whenever it's required, 2 bytes will be allocated. And again, when it's required, another 2 bytes area will be allocated because they are going to access it one by one. Here you
Okay, sir.
8 byte, whereas here you need only 4 byte.
Okay, here the 8 byte is ready made, and here additional 2 bytes are given if required.
Which one? In structure, 8 bytes
I
are
mean, in 8 bytes are, yeah, 8 bytes are already existing.
yes.
Whereas in union,
Only
like
4 bytes
additional
are
two
allotted.
bytes are given when required.
Dynamically, the values with the memory will be allotted from these 4 bytes only.
Yeah, okay, sir.
Okay. So 4 bytes, if it's a memory, what will happen? Got it? So each location in a memory can store a byte. Understand? Then one
Yeah, yes, sir.
4 bytes area will be given for a 4 bytes memory area will be given for a union. Okay. Whereas in a structure, what will happen? You'll have a memory area. So here, like this, you will be having many locations in the memory. Okay. So how many bytes are required? 8 bytes are required. So here 2 byte will be given. Then somewhere else another 2 bytes will be given. Then somewhere else another 4 bytes will be given. Like that distinctly it will be given. So dedicatedly we need to give different memory areas. Whereas in union it's not like that. 4 byte is required. So whichever you want to accommodate, you can accommodate and make use of it. That's the policy. Okay, done.
So while in a program, which will come more handy, sir? Structure or union, sir? Structure or union, sir? Most probably.
Which one? Handy means no, both you can use here, only in terms of implementation only. When you go for a memory implementation or a memory optimization, then the union is the better one.
Okay, sir.
Okay, union is a better choice. Structure is already there in the C also. Understand?
And the union is there only for C++, sir?
Yes, yes.
Oh,
Okay,
yeah. Okay, sir.
fine. And anybody else having class at 11 o'clock? Okay. So next what we'll do, we'll discuss about enumerated data type. Enumerated data type is also another user defined data type. It's another user defined data type. And here in enumerated data type, what we can do, the user can attach names to numbers. Attach names to numbers. That's the first thing. And the use of enumerated data type will help us to understand the program easily. Understand the program easily. Then the enum is the keyword that we use. Enum is the keyword that we use, and this assigns the values starting from 0, 1, and 2, and so on. Continually, it will be going on. And if you want, we can override these values also while writing the program. Okay.
Sir, I have EMDT class, sir, at 11 o'clock.
Yeah, I'm winding up here. Another 2 or 3 minutes, I'll be winding up.
Okay, sir, no problem. Okay, sir, thank you.
Okay. Then we have what? The syntax. Okay, syntax, how it goes on. So we have the enum. Enum is the keyword, and name you can give whatever the name that you want related to your work. Then we can have a list of values that's separated by comma. List of values separated by comma. Then how to use it? Like any other data type, we will declare the name of the data type and we'll declare a variable for it, and finally we are going to make use of it. So it's a user defined data type which associate names to the numbers, and it's quite easy for us to understand the program while using the data type, and it assigns the numbers from 0 to so on, 0, 1, 2, 3, and continually it's going to assign the numbers. And also as a user, we can override the values by following this syntax and declarations. Understand? So with this introduction to enum data type, I'll stop today's class, and next class we'll discuss in detail about how to write a program for enum data type.